Exercise 5.2, question number 9. Prove that the function f given by fx is equal to mod of x minus 1 when x belongs to R is not differentiable at x equals to 1. Okay. So fx is given what? Mod of x minus 1. So I will simplify this. So therefore fx is equal to x minus 1 when x is greater than or equal to 1. When x is greater than 1, x minus 1 will be positive. So mod of positive will be positive. Mod of x will be plus x when x is greater than or equal to 0 is equal to 1 minus x or minus of x minus 1. I'll write 1 minus x. 1 minus x when x is less than 1. When x is less than 1, x minus 1 will be negative. You see, you put any number less than 1, you put 0. 0 minus 1, minus 1. So this number is negative. So mod of negative will be negative of negative number. So that will be positive. So this will become what? 1 minus x. When we open this, this will become minus of x minus 1. When x is less than 1, this is negative. So mod of negative will be minus of that. So minus x plus 1. So finally you get 1 minus x. Okay. Now f dash x is equal to what? Limit t tends to x ft minus fx upon t minus x. This is the formula. F dash x means derivative of f at x. Derivative of f at x is given by formula limit t tends to x ft minus fx upon t minus x. Same way f dash a is equal to what? Limit x tends to a fx minus f of a upon x minus a. I have just replaced x by a. So wherever you see x by a and x by a, and this t I will replace by x. So t in place of t I have written x. Okay, same thing only. Okay. So therefore f dash 1, we want to find out the derivative at 1, means not a differentiable will show, but f dash 1 is equal to what? Limit in place x as it is, x tends to 1 fx minus f of 1 upon x minus 1. Wherever a you see, there you put what? 1. Okay. So f dash 1, that is equal to limit x tends to 1 fx minus f of 1 will be what? 1 minus 1 0. Here in place of x you put 1. 1 minus 1 0. Mod 0 is 0 upon what? X minus 1. So that is equal to, I will write limit x tends to 1 fx upon x minus 1. Now if the limit of this function exists at x equals to 1, then we say function is differentiable at 1. If the limit does not exist, then the function is not differentiable. Okay. So for the existence of the limit, I will find out right hand limit and left hand limit. So first I am finding right hand limit. Limit x tends to 1 plus fx upon x minus 1. So that will be limit x tends to 1 plus. X tends to 1 plus means x is a number greater than 1 but near to 1. So 1.01 let us take. So x is greater than 1. When x is greater than 1, what is the function? X minus 1 upon what? X minus 1. So this x minus 1 will get cancelled. So what is left? 1. Limit of constant is constant. Limit of 1 is 1. Now I will find out left hand limit. So limit x tends to 1 minus fx upon x minus 1, that is equal to limit x tends to 1 minus. When x tends to 1 minus means x is less than 1. When x is less than 1, what is the function? 1 minus x upon what? X minus 1. Now when we cancel this, we will get minus 1. Or from numerator I am taking minus common. Limit x tends to 1 minus common x minus 1 upon x minus 1. So x minus 1 will get cancelled. What is left? Minus 1. So limit of constant is constant. So limit of minus 1 is minus 1. So here RHL, that is right hand limit, is not equal to left hand limit. So therefore what we will say, limit x tends to 1 fx means this fx minus f of 1 upon x minus 1 does not exist. So therefore function is not differentiable. Function is not differentiable at x equals to 1.